But first, let's understand the meaning of the word function. This is important, right? So let's go and ask a question to ourselves. Look at this. This is a windmill. And what kind of question can you ask about it? You can ask a question like, what is the function of a windmill? And when you Google that, this is the answer that you get. The main purpose of windmill is to convert wind energy into electrical energy. So what are you trying to, what is the equivalent? What is this standing for? This is standing for, this word, purpose. Okay, every function has a purpose. If you know the purpose, then you can build a function. If you know where the purpose uh, is used, then you can call a function at that particular time. Okay, so that's how you envision the word function. So in the software paradigm, you're going to be using a lot of functions. I'll give you an example. Say, suppose you have a calculator. And see, the calculator has all these operations, right? Plus, multiplication, minus, addition. Let's suppose you take an example, x raised to y. Okay. And suppose to this x raised to y, you give 7 and 3. Okay, so what does it mean? It means that what you want to do is you want to raise 7 to the power of 3. Next, you will change these two parameters. Maybe you want to do 3 raised to 2. Still, you will press the same button, correct? Anything raised to anything, you will press this button. So what it means is what is supposed to happen when you raise something, some number to another number, what is supposed to happen? This entire operation, or if you will, you can call it process. This entire operational process is defined clearly in a function. So all of these are now functions. Whatever you're seeing here, this is a function, this one. Everything is a function. Okay, maybe not this, but yeah, definitely the log and the natural log and the square root. All of these are operations which are embedded, right? And for this, you can keep changing this, right? It's your wish. These are, for us in our example now, these are parameters and these are the functions. So functions will take parameters as input and do its process. That's what is the general idea. But let's build another analogy over it so that we can understand the lambda function. Okay, another analogy. Suppose, take for example, this bubbly mocktails, different recipes of mocktails. So just learned that they have this amazing new combinations of different kinds of mocktails. You can go to this particular website and you can get more recipes if you're interested, if you were inspired by this video or something, right? You can do that. Nevertheless, let's just get back to our main purpose of this code, which is understanding a lambda function. So have a look at the first mocktail example here, which is your berry bubbly mocktail. Okay, what does it consist of? 3 ounces of Sprite, 3 ounces of raspberry lemonade, 1/3 cup of muddled raspberries. Okay, take all of this, then mix all of it and garnish with fresh or frozen raspberries. This is a proper recipe, a step-by-step guide. Now, if bubbly mocktail were to really open a store somewhere, maybe it is somewhere, we don't know, they would hire somebody to take care of it and train a particular person to create or to quickly fix a very bubbly mocktail for somebody, the instruction is clearly written. Okay, so the clear process of the instruction, if it is written, you can completely see this whole thing as a function. We can name the function as berry bubbly. Suppose you want to write a function for berry bubbly, let's just keep it as bb. And what are the parameters bb is going to take? It's going to take some Sprite. It's going to take some raspberry lemonade. It is also going to take muddled raspberries. Okay, that's what it will take. And now you would like to build what is going to happen for that. Okay, so what are you going to do with the Sprite? You're going to multiply this, then multiply 3 times of RL plus 1/3 of MR. You do all of this, and then you garnish with fresh raspberries. Now this is your entire function to create a BB, or a bubbly, berry bubbly, as they call it. This is the function. Similarly, have a look at the second one. It's a different function. It's a different recipe altogether. But sometimes in the middle of something, what if you want to try out a combination? What if it occurs to you that you would like to try what happens if you take 3 ounces of raspberry lemonade and 2 ounces of limeade concentrate, and then add it to non-alcoholic sparkling rose. There's no recipe here which we can see, but you really want to try this. It's just a trial. You don't want to call it anything. We just want to try it. That's it. Because we have everything here in front of us. This person, suppose this person who knows how to make very bubbly and sunshine state of mind and bubbly party, he knows all the three, is good at it, but he or she is now interested in trying out something new. While before even trying this, do you think this person is going to be worried about naming the mocktail? We don't even know if it is going to work. We're just trying, correct? So if in that case, you are just taking a bit of this, bit of that, bit of this into just another empty cup, whose name or where you're going to put the cup or just throw the cup away later. That's it, right? You taste it. If it's good, then maybe you change a little more combinations until you get a satisfied taste. That's what you're going to do, right? Similar thing happens in coding, right? In coding, you would require a function whose name is not important. Then what is important? The result. Okay. We just need a concise single line code which can act on different parameters and produce the results for us. If this is what you want, then you can go ahead and use a lambda function. Okay. Now, like everything, like a function has its own template, lambda functions will also have their own template. So in the next section of this video, we're going to be looking at a Python implementation of Lambda functions.